So the third video in our higher vector series is on collinear points. So when a series of points lie on the same straight line, the points are said to be collinear. Now we've already looked at collinearity with points on a straight line. And we showed that 3 points A, B, and C are collinear by proving that the gradients of, say, AB and BC are equal, which means that the lines are parallel, and then show that they are collinear because the point B lies on both line segments and is therefore a common point. So you can see we've got two examples here of a collinear example where we've got a line segment ABC. You can clearly see that the gradient of AB is the same as the gradient of BC, and because they share a common point, therefore they are collinear because we've got parallel gradients with a common point. PQR are not collinear because although there is a common point on this line segment, the gradient of PQ is different from the gradient of QR, and so therefore they are not collinear. So we can use a similar approach for points in 3 dimensions using vectors. So here we can show that vectors are parallel if one is a scalar multiple of the other. So remember in general that vectors u and ku are vectors in the same direction such that the length of the vector ku is k times the length of vector u. So to prove that 3 points A, B, and C are collinear, in 3 dimensions, we need to find the position vectors around a common point, for example, AB and vector BC. Then we need to show that AB is a scalar multiple of BC, and that will give us the ratio that B divides AC, and we do that by taking out a common factor. And then step 3, we need to explicitly state that vector AB is parallel to vector BC with a common point B. Hence, A, B, and C are collinear, and state the ratio if required. So let's have a look at an example. We're going to prove that the coordinates A, B, and C are collinear, finding the ratio that B divides AC in. So A is the coordinate 3, 4, 1. So we would therefore know that it has the position vector 3, 4, 1. Coordinate B has the position vector 9, 1, negative 5. And coordinate C has the position vector 11, 0, negative 7. So now we need to work out our vector AB and vector BC. So if we draw ourselves a sketch just to remind us what we're looking at and to make sure that our vectors are going to be in the right direction. We've got vector A, we've got point C, and we've got a common point B. Now remember what I said, we have to make sure that the vectors are pointing in the same direction. We can't have AB and CB because that's not going to work. So we need to work out vector AB and we need to work out vector BC. So we know that vector AB we can be found by doing B take away A, where B is 9, 1, negative 5 and A is 3, 4, 1. So 9 take away 3 is 6. 1 take away 4 is negative 3, and negative 5 take away 1 is negative 6. We also now need to work out vector BC. So BC is going to be C take away B. So C is 11, 0, negative 7. And we're going to take away B, which is 9, 1, negative 5. And so 11 take away 9 is 2, 0 take away 1 is negative 1, and negative 7 take away negative 5 is the same as negative 7 plus 5, which gives us negative 2. So we can see that AB is a scalar multiple of BC, and we can take out that common factor now. So we know that we would need 3 of BC in order to get 1 of AB. So the final step we need to do is work out that vector AB and BC are parallel in the ratio AB equals 3BC. We need to make sure that we state that there's a common point B. And then we say hence A, B, and C are collinear. Now, obviously, if A, B, and C are not in a ratio, then it doesn't matter that there's a common point. It means that they would not be collinear.